Hello viewers, in today's class we are going to take up a very important problem in integration in which the greatest integer function is involved, right? So here we have to integrate this function from the limits 2 to 3, right? So here we have the greatest integer function 2x minus 5, right? So let us start. So suppose we denote this integral by the letter I, and here we have the function f of x, that is greatest integer function 2x minus 5, right? So we have to calculate the integral from 2 to 3 f of x dx, right? Now here we see that this is 2 is the lower limit and 3 is the upper limit, right? And so we can write x, the value of x, it belongs to the interval 2 comma 3, right? So when x belongs to 2 comma 3, then 2x minus 5, it belongs to minus 1 comma 1, right? Why? Because when x belongs to 2 comma 3, it means when x is 2, then 2x minus 5 is 4 minus 5, that is minus 1. So here we have minus 1, and when x is 3, then we have the value of 2x minus 5 as 2 times 3 minus 5. So we have 6 minus 5, that is 1, right? Okay, so now here we see that 2x minus 5, it belongs to the interval minus 1 comma 1. So if we represent this interval in the form of number line, then here we have minus 1, then we have 0, and then we have 1, right? Okay, so now our next aim is to express this function in terms of intervals, right? So what we will do, we'll write the function f of x as in the interval minus 1 to 0, right? This is the first interval, and the second interval is from 0 to 1, right? So when we take 2x minus 5 in the interval minus 1 comma 0, right? When 2x minus 5 it lies between minus 1 and 0, then the value of f of x, that is greatest integer function 2x minus 5, is minus 1, right? Due to the definition of greatest integer function. Okay, and when 2x minus 5 it lies between 0 and 1, then the value of f of x is 0. Now let us see how. Now let us take an example. See, when 2x minus 5 lies between minus 1 and 0, right? Let us take a value here. Suppose we take minus 0.5, clear? And here 2x minus 5 lies between 0 and 1, and let us take for instance a value, say 0.5, clear? So here we have negative 0.5, here we have positive 0.5. So when this 2x minus 5, when 2x minus 5 it lies between minus 1 and 0, it means the value of 2x minus 5 is minus 0.5, then the value of greatest integer 2x minus 5 is minus 0.5 greatest integer, and then due to the definition of greatest integer function, less than or equal to minus 0.5 is minus 1, right? So the value of this greatest integer function minus 0.5 is minus 1, and similarly we have other values. Now when this 2x minus 5, it lies between 0 and 1, and for instance we are taking 0.5 here. So when we have 0.5, then the value of greatest integer function 2x minus 5 is greatest integer 0.5, and again due to the definition of greatest integer function, the value of greatest integer function 0.5 is greatest integer less than or equal to 0.5. So obviously 0 is the greatest integer which is less than 0.5. So the value of this function is 0 here, and here the value of this function is minus 1 as per the intervals, right? Okay, so now what we will do, now we will solve these two inequalities for x. Now let us take this one. So here we have minus 1 less than or equal to 2x minus 5 and less than 0, right? So now if we solve this inequality, then we have adding 5 throughout, then we have here 2x minus 5 plus 5, and here we have 0 plus 5, and here we have 5 minus 1 4, here we have 2x, here we have 5, and dividing throughout by 2 we have 2 x and less than 5, right? So the first one is here we'll have 5 by 2, right? So we have solved this inequality for x, and we have got the value of x in the interval from 2 to 5 by 2, right? So here we can write 2 less than or equal to x and less than 5 by 2. Now let us solve this inequality. So here we have 0 less than or equal to 2x minus 5 and less than 1. Adding 5 throughout, we have 0 plus 5 here. Here we have 2x minus 5 plus 5. Here we have 1 plus 5. And here we have 5. And then 2x. And here we have 6. And dividing throughout by 2, we have 5 by 2 here. Here x, and here we have 3. Right? So here x lies between 5 by 2 and 3. So here we can write 5 by 2 less than or equal to x and less than 3, right? Now viewers, this function f of x can now be rewritten as fx is equal to minus 1 when x lies between 2 and 5 by 2, right? And f of x is equal to 0 when x lies between 5 by 2 and 3, right? Okay, so now we can integrate this function from 2 to 3, and see here we have 2 and here we have 3. Clear? So it means we have now expressed I as a sum of two integrals, that is I1 and I2. What is I1? I1 is from 2 to 5 by 2, that is from 2 to 2.5, and here we have f of x dx, and the other integral is from 5 by 2 to 3 f of x dx, right? So due to these two intervals, this integral is now we have divided it into two parts, and due to the additive property of definite integrals, right? Okay, so now when x lies between 2 and 5 by 2, the value of f of x is minus 1. So here we'll have 2 to 5 by 2, and here we have minus 1 dx plus, and when x lies between 5 by 2 and 3, then the value of f of x is 0. So here we have 5 by 2 to 3 and 0 dx, right? So now the value of this integral is 0 here, and here we have minus 1, and the integral of dx is x, and the limits are from 2 to 5 by 2. Clear? So therefore I can be written as minus 1 is here, and we have to just substitute these two values and we'll take the difference, and we have 5 by 2 minus 2, and then we have minus 1 times this is the 5 minus 4 over 2, that is half. So we have minus half, that is minus 0.5, right? So therefore